we're going to take a further look at writing some of these equations, both in slope-intercept form and point-slope form, making sure we know what pieces we want to look for, what the slopes mean, and then kind of look at everything as a whole, and then look at one thing at the end that requires basically 4 steps, and something you'll see that on the quiz. So, write the equation of each line in the given form. Okay, so again, you're given 2 points. You want to write it in slope-intercept form. Okay, to get the slope-intercept form, you need to start, as I mentioned, in point-slope form first before you go to slope-intercept form. So we have 2 points. Let's find the slope first. So we're going to have m equals -5 minus 3 over 3 minus -1. So you get -8 over plus a positive. That becomes -8 over 4, or also equaling -2. Okay? So we can't go straight to slope-intercept form right now. It's not y equals -2x and then -5 or +3. You can't just use one of those y's. So what you need to do is put it in point-slope form. So what that's going to be is your y minus y1 equals m times x minus x1. Put it in that first. When in doubt, put it in that form. Take it to slope-intercept. So we'll take y. I'll use this point. Y minus 3 equals -2 times x minus a -1, making it a positive. Now go ahead and get to slope-intercept form. So 2 steps left. Y minus 3 equals -2x. Distribute -2. And the last part, add 3 to both sides. So we get y equals -2x plus 1. So again, start in point-slope form first. You need a point, you need a slope. Find the slope, pick either point to use, and then go get it in slope-intercept form. Okay, let's take a look at another one. A couple ways we can do number 2. Want to decide if they're parallel, perpendicular, intersect, or just the same line. So again, to look at that, we always want to look at it in slope-intercept form. We could probably tell what slope was here, right, just looking at this and this, but we don't know if they're the same line or not for sure. So what we want to do is make sure we get in slope-intercept form. So this one, pretty simple, add 3 to both sides, so that one's going to be y equals -1/2 x plus 3. Not bad. Other one's not bad either. Distribute, so we get y minus 5 equals 2x plus 6, and add 5 to both sides. Y equals 2x plus 11. So here's one equation, here's the other equation. Okay, they're clearly not the same line. They're not parallel because they're not the same slopes. If you look at their slopes, though, you can see one's -1/2, the other one is +2 or +2 over 1. So we would say that these are perpendicular. Number 3, graph the line x equals 4 and the line y equals -2 and identify their slopes and their relationship. Okay, so if we look at this, x equals 4, you go over to x on the x-axis, 1, 2, 3, 4, you go over to 4, and then graph a vertical line. You wouldn't want to go overlapping that x-axis. Then go y equals -2, so go down to -2 on the y-axis, and give yourself a horizontal line. Their slopes are 0. This one's undefined. We should know that from the first day we talked about these. And the relationship is, well, if one's an undefined slope, the other one's a slope of 0, they're not opposite reciprocals, but you know one's horizontal, one's vertical. So we know that these are perpendicular to each other. Okay, a couple more. Write the equation of the line in slope-intercept form that is parallel to y equals 1/2 x minus 6 and goes through this point. Okay, so we know the point of our new line. We also know we want the slope to be parallel to this original equation. The original equation's slope is 1/2, so we want our slope to be the same. Okay, we have a point, we have a slope, pretty simple now. Plug it into point slope form first, then take it to slope intercept form to figure out what it looks like. So again, plug it back in just like we did the first one with your point and your slope. Plug it in point slope form, go to slope intercept form. I want you guys to finish 5 for tomorrow. Write the equation of a line in point slope form, so we don't have to keep going after point slope, we can stop. That is perpendicular to 6x plus 2y equals 12 and goes through 6, negative 4. So again, we know our point that we want to go through. We want to figure out what the slope needs to be though, so we have a little bit of work to do. We always want y by itself to figure out the slope. So I'm going to subtract 6x. So 2y equals negative 6x plus 12 divided by 2. Y equals negative 3x plus 6. So here's my other piece of information that's important. I have this slope of that original line is negative 3, but I don't want the same slope. I want a perpendicular slope, so that's going to be 1 over 3. There's my point, there's my slope. Go ahead and plug it into, again, your point slope form. In this case, you don't have to keep going, just plug it in and stop after you have it plugged in. Finish that little last step for tomorrow. Okay, a couple other ones I want to look at, some different types. Number 7 and 8. Number 8 is going to be a little bit longer problem. Number 7 is going to be something that you'll see as well in the quiz. The 3 given points form a triangle. Is it a right triangle? Okay, so think about what a right triangle looks like. A right triangle or a right angle. So we want something like this. Now if you had graph paper, that would be helpful. We could look at this on a piece of paper and graph it and do all that, but there's actually a little bit easier way to do it when we don't have graph paper. All we're looking for is a slope or 2 slopes that are perpendicular to each other. So if this slope was like 2, this was negative 1/2, we know that we have a right angle. So we need to check all 3 slopes. So we need to check KL, we need to check LM, and we need to check KM. I'm going to get you guys started on the first one. I'm going to let you guys try LM and KM for tomorrow and then see what we come up with. So KL, find the slope between the two. It's going to be 1 minus 4 over 2 minus a negative 2. So it becomes negative 3 over, that's plus a positive, 4. There's KL's slope. Find LM and KM's slope and then decide, do we have perpendicular lines anywhere, or in other words, do we have a right angle? Last thing, make sure you guys pay careful attention because I am going to go through 8 and I'm going to ask that you guys do 9 for tomorrow. They're identical type problems, just obviously with different slopes, or different points rather. So we're going to look at the step-by-step problems that we do here. So we have 2 points. What I want you guys to do is write the equation of the perpendicular bisector of the segment with the given points. In other words, perpendicular means we want a right angle. Bisector means cuts in half. Okay, these are things that we've talked about before. So if we look at this original problem, we have these points 6, 0, and that should be A is 6, 0, sorry. A is 6, 0, and B is negative 2, negative 6. So that's a line segment here. What we want to do is find the perpendicular bisector. So the line that cuts it in half right here, right in the middle, so that this is true. And it also has to be a right angle. So we want to find out what that is. Okay. So in order to do that, it takes 4 different steps. Okay. First thing, find the midpoint. We want to find out what that point is that's halfway through. So a little bit of review. Midpoint is going to be our, let's say, MID P equals that's our test scores. So we have our average over x's, average over y's. Okay, so let's see what that comes out to be. So we have 6 plus a negative 2 over 2, and 0 plus a negative 6 over 2. 6 plus negative 2 is 4, 4 divided by 2 is 2. 0 plus negative 6 is negative 6, divided by 2 is negative 3. Okay, so that point we now know is 2, negative 3. Okay, the average is halfway in between. So next step, find the perpendicular slope. Okay, so we want the perpendicular slope, so what we need to do is find the slope of AB and then go from there. So again, we want to make sure we get that perpendicular slope. Find slope here. Again, this is all review. y2 minus y1 over x2 minus x1. So what we're going to have here is m equals negative 6 minus 0 over negative 2 minus 6. So that's going to give us negative 6 over negative 2 minus 6 is negative 8, which equals 3 over 4 if you reduce it. Don't get too excited that you found the answer. Make sure you go back and see what you highlighted. I don't want the slope of AB. I want the perpendicular slope, which is going to be negative 4 over 3. That's my important piece of information. So we found a point now. We know what the slope is. It's negative 4 over 3. Okay, so we're almost done. Last part is putting it in point slope form and then finishing it up and making it slope intercept form. Point slope form, again, here's some review. You don't have to write this part down. If you know it already, I'm going to. So we have y minus, either point you want to use is fine. So I'm going to go ahead and use A. Y minus 0 equals m, which is negative 4 over 3, times x minus 6. Done. That's point slope form. Last step, rewrite that. So y minus 0 equals negative 4 thirds times x minus 6. Go ahead and distribute. So y minus 0 equals negative 4 thirds x. 4 thirds times 6, or 6 over 1. Multiply straight across. 4 times 6 is a positive 24, because it's a negative times a negative, over 3. We can reduce that in the next step. Y minus 0 equals negative 4 thirds x plus 8. Nothing's happening over on that left side. 0 doesn't change anything. So that is our final answer. That's the equation of that red line I drew originally. So again, perpendicular bisector. It makes a right angle. It also bisects that original segment. So you need to find the midpoint. Then find the perpendicular slope. Write in point slope form first. Then go ahead and do your distribution and add your number over to get to your slope intercept. I want you guys to either rewind and watch this again if you're not sure how to do it, or go ahead right now and do number 9. Good luck. I will see you guys tomorrow.